Okay, so we are live. Okay. Okay, yes. Okay, so we can begin our classes, and the video will be automatically added after the live stream. So let us begin. Let me just. Okay, so organic chemistry. Okay, so. Okay, so let us go to the page 1302. 132. 132. Sorry. 132. Okay, so basically this is the starting of organic chemistry, and to simply identify organic chemistry, the main portion is hydro and carbon. These are two words we can see. So if we write it down, hydro carbon. Okay, okay, these are two words we can see, which is hydro and carbon. So what does hydrocarbon means? Can you tell me what does hydro and carbon means here? Yes, in some sense the word is just as we say. Carbon means like carbon molecules, and hydro means that hydrogen molecules, right? So basically hydrocarbon is the combination of these two elements, which is one is carbon and another is hydrogen. By combining both of these elements, we create a new compound which we call hydrocarbon, this term right here. So basically organic chemistry is basically related to hydrocarbon, or in some sense we can say hydrocarbon is the organic chemistry, because if we want to identify which one is organic material or organic anything, like you can see in a packet or any natural product, you can see 100% organic term are written, right? 100% organic, 100% pure, these terms are written in many of the packets you use in natural products in your home, in your maybe food, right? So you can see there is a term called 100% organic. So what does this mean is that it's 100% natural and safe and no chemicals are added. So organic chemistry is the heart of everything, in even the drinks we see. Yes. Oh, wait a minute, something is wrong. Wait. Okay, I think now is okay. So as I was saying that carbon and hydrogens are the two atoms that consist of hydrocarbon, and we can, in many of our natural products we can see 100% organic is written, 100% organic. Suppose any packet you take, organic product, of course, you can see there's a term called 100% organic written on it. So what does it mean? Well, it means that it's a purely natural, no chemicals, no preservatives are added in order for the conservation of the product or any preservation of the product. No extra chemicals were added, so it is very safe to take this kind of product in our body. That's what it defines. So hydrocarbon, we can say every material we see around us is made of hydrocarbon in one sense. Even our phones, even our tables, even our pens, all are all hydrocarbons are the heart of every product that we use. Even the toothpaste, if it's natural, it consists of hydrocarbon. The brush, even the phone's material in some sense are hydrocarbon, of course. So we can say all the product in our consist of hydrocarbon. So in this chapter we are gonna learn about many things, of course. A little bit critical in some sense for you. I think you haven't seen this kind of pictures, right? Methane, ethane,
Mm,
butane, right?
let me see. Yeah, I've never seen this before.
Okay, so here we can say that. Okay, so here, but if we write it down some more times, it will get easier. Of course, we have to practice a lot. But before we go to the practice in this kind of figure, a little more about hydrocarbon, or this part right here, the alkanes, which are the CC single bonds. So this part we'll discuss right now. Okay, so in our nature there are a lot of hydrocarbons present. Okay, and we can categorize it in many sense, but firstly I want you to learn these three categories, which is three names are alkane, alkene, and alkyne. These are the three names of the hydrocarbon, or we can say subgroup of the hydrocarbon. Hydrocarbon can be of many types. Hydrocarbon can be of many types. It can be sometimes alcoholic, it can be sometimes acidic, right?
Yes.
Acidic or alcoholic, and it can sometimes be just a simple plain chain. You can say simple chain or simple compound, nothing else. Like carbon and hydrogens are present, nothing else. So it can be of many types, but firstly we're going to discuss about these three right here, which is alkane, alkyne, and alkene and alkyne. These three all are different names, as you have to be careful when you write it down, because just one word is different in each of this term, and if we mark it down, the words are, here is A, here is E, here is Y. So depending on this word, the pronunciation will change. Some is alkane, as I said, some is alkyne, and another is alkene, alkyne. Okay,
Hmm.
alkane, alkene, and alkyne.
Okay. Alkene, and alkyne.
Alkyne. Okay. Okay. So basically, what it says here, that in carbon has four hands. As have we discussed about the carbon and its property?
Carbon. No, sir. No.
Okay, so let me discuss about carbon a little more, because you have to understand the carbon property before we get inside the carbon, get inside the hydrocarbon, of course. Okay, first of all, think about this way, that why is the hydrocarbon core of any products, or we can say hydrocarbon is very common in nature, or a lot of products are related to hydrocarbon. Firstly, we have to understand that. Okay, the thing about it, let me summarize it simply. First of all, we have to understand the nature of the carbon, the nature of the carbon's nature. We can say the topic is carbon's nature, or carbon's property, you can say, in some sense. Carbon's
Okay.
property or carbon's nature. What do carbons are attracted or reactive to? Okay, firstly we have to understand the periodic position of the carbon. Periodic table. Firstly we have to go to the periodic table, as we can see. Okay, so let me, any picture, we can take any picture of the periodic table, and of course we have discussed uh, some knowledge about the periodic table. And as we can see, where is the carbon position at? You can see it is at 14 number, right here,
Yeah.
14 group.
Wait. So its atomic number is 14.
No, atomic number,
Oh.
how much?
Pardon, sir?
Atomic number how much?
Just hold on, sir. Okay. Yes, sir. Continue.
Okay, so atomic number how much of carbon, do you remember?
Uh. Okay. Yes.
Okay, so atomic number is 6, right?
6.
6.
Oh, it doesn't show here.
Oh, that's why I'm choosing another picture. Suppose we, yeah, we can take this picture right here. This will show here. Okay, so it's 5, then 6. See?
Okay. Yes. Yeah. Now I can clearly see it.
Okay, and in your book there is a periodic table. Of course, find it in some of the pages, some of the chapters earlier, I think. Okay.
There's a whole periodic table at the back of the book.
Yes, so follow it and see how the periodic tables are marked, or a layout.
Okay. So wait. So sir. Okay, so the number on top of the element is the number of the element that came.
Number of the top of the, yeah, number of the top of the element is the atomic number, and this portion right here, 1 2 13, then 14 15, these are the groups of the periodic table, and the side numbers are the period.
Okay, so I could say that hydrogen is the hydrogen because there's
At the
my
start,
periodic table looks a bit different. Yeah, it does look a bit different.
it should look the similar, depending on, is it like this one, or this one, every periodic table is same, but
Oh,
can be written a little bit different, but the concept is same, nothing changes. This one is also a periodic table. So top numbers are represented as groups, and the left side serial, or we can say the vertical serial is represented as period. So
P.
this
Okay.
portion,
Yeah.
so this period, we have discussed it in the in the periodic table class, but let me just recap it, that the vertical direction of the numbers represent period and the horizontal direction represents the groups. Okay, so this
Okay.
represents the groups. And what is the groups and the periods? The period is the vertical numbers of the table, and the groups is the horizontal numbers. And by understanding
Okay, sir.
raindrops detected 70% of the last okay, give me 1 minute. Okay.
Yep. Okay. Okay, sir.
Yes.
Okay.
Yes, let's start. Okay.
Hmm.
Mm, I don't know what's the issue, but the
Is it
video
something
show. Yeah, something about
something
the
wrong with your
live stream.
computer?
No, not the computer, but the I think the internet, of course.
Oh.
Something about the live stream is like saying poor connection. Mm, it's detecting some frame drops. That means okay. Just let's just continue. I'll just fix it later. Okay. First, so as I was saying, that it's in the period and in the group. So, so here is a period and here is a group, and the carbon's position is, we can easily say, period number 2 and group number 14. Period 2 and group 14 is the periodic position of the carbon, and you can see the carbon's position is like is in the middle, right? It's the distance from this and this, we can say, it's almost in the middle of the periodic table. And for that nature, for that reason, carbon's nature is somewhere like in the metal and non-metal. Carbon can react. Okay, carbon can react as metal and non-metal. So carbon has both nature in some sense, but though it shows non-metal more, but it can react in both nature. Okay, so we have to be careful that carbon can show both nature, metal and non-metal, and of course, for that reason, it has a bonding tendency with a lot of material. It can bond with every single elements we can think of. So carbon can easily bond with uh, any metal and non-metal depending on the nature, and carbon has four hands in some sense, that in order for any elements to bond, it should or it must need some kind of you can say hands. We're gonna denote this. Suppose here I'll draw another carbon. Okay. So as I was saying that in some sense we if we're discussing carbon, we have to understand the hand concept of carbon, that how many elements it can capture in some sense in order to make the bond happen. So it's a topic about bonding. You can say bonding, creating new materials, creating new materials, or new compounds, etc. But carbon has four hands, and with these four hands, it can capture four elements. For example, when we are discussing CH4, that means this is a methane, right? What is the symbol of the methane? You already know, CH4, right?
Yes, CH4.
CH4. So what does this represent? That one carbon is holding like four hydrogen. One carbon is holding four hydrogen.
For hydrogens, yes.
So carbon has hands. These hands we are denoting in chemistry or terming this bonding is like a hand, because with hand you can grab anything, right? Or grapple anything, right? With your
Yes.
hand you can grab anything, and you can hold it, right? So in chemistry we are comparing this bond with hands. We're gonna say it like this way, that carbon can hold 4 elements because of its valency. So it has the power to hold 4 elements, and here we can see in CH4 carbon is holding like 4 hydrogen in order to make the bond happen. And this bond has a special name, which is a covalent bond. Covalent bond. Okay, so this bond has a special name, which is a covalent bond, and we can say it here that covalent bond is where the electrons are shared. We're going to discuss it later, but remember the bond's name is covalent just for now. This is another topic, we have to discuss it later, but for now we can say that here the carbon has 4 hands, and with these 4 hands it can grab or hold 4 elements. And here in CH4, for example, in methane, this is a CH4, a carbon is holding like 4 hydrogen in order to make the bond happen, or new bond creation, right? So here we can see that this is happening. A carbon is holding 4 hydrogen. Similarly, if we analyze another one in our book, which is ethane, then we can also think of it like this way. When we discuss about ethane, suppose I'm now discussing about ethane. Okay, so
Okay.
ethane, these are all alkene example. Okay, remember it, this I'm giving you all alkene example: methane, ethane, propane, butane. How I'm gonna discuss it in our next class, but for today it's all named after alkane. Okay, it's all are alkane. And how I understand this is all are alkane? 3 alphabets. Do you understand what I said?
No, sir.
Propane. Okay,
Propane.
first of all spell alkane. ALKANE, right?
ALKANE.
Right?
Alkane.
Alkane.
Mm.
Okay. And these are all alkane example: ethane, propane, butane, then I can give you another example which we have discussed before, which is methane, right? Methane, right?
Yes.
Okay, so can you tell me what's the common in all of these examples right here?
So, may you repeat this?
What is the similarity or common in all of these 3 things here, or 4 things here? What is the spelling? Just follow the spelling. Where is the spelling similar?
They all have A and E
A
at
and
the
E,
end.
yes. So that's how you can
Oh,
understand this is
okay.
alkane or not. A and E, just follow this, right?
Okay. Yes.
So these are all alkane examples, right?
Yes.
All are alkane. That's how I understand these are all alkane examples. And because they are all alkane, they follow a simple formula, as we can say. And the formula is quite simple, that how many carbon and hydrogen should be present in an alkane. So if the carbon is N, the hydrogen should be 2N plus 2. What did I say? If the
No, so
carbon of
we,
it should be 2N plus 2. So let me give you an example. For example, if the carbon number is 1, suppose n is equal to 1, the carbon will be 1 and the hydrogen should be how much? 2 into 1 plus 2. Is it okay?
Yes.
Hydrogen is 2 into 1 is 2 plus 2 is 4.
Wait, what? Wait, what? Wait, what? Wait, what? What?
Okay, observe this line here. Do you have any confusion in this line? Just follow the formula of alkane formula.
CCNH2N.
Plus 2.
Wait. Plus 2. Okay. And go away. It's not time. Scissors. Mama needs them. Okay, yes, sir. Continue.
Okay, so I said, okay, so as I said here, the formula is CnH.
CnH2N plus 2.
Yes. So
Okay.
depending on this formula, we're gonna denote every compound that is related to alkane. For n is equal to 1, then what should be for the CH portion, or the carbon and hydrogen, you can say, or alkane?
1.
C is equal to 1. Sorry, carbon numbers will be 1, and hydrogen, how many?
Oh, 2.
2 plus 2,
Wait, no. 4, 4, 4, 4.
4. Okay, that means we can write CH4, right? Because 1 means nothing, right? Like C is just one single C, so we can denote it
Yeah.
like this way. No problem, right? That
Hmm.
means this is CH4, and what does CH4 denotes? It's like methane, right? This is the methane.
So this is methane.
Methane.
Wait, so then what does the N... What is N?
N is the number of we can say carbon and hydrogen in the formula here. So N can be denoted like carbon and hydrogen in the formula, and depending on this we can easily write which one will come after which, is methane or butane or propane or ethane. Okay, so for example, if now the formula is like CnH2n plus 2, right? This is the formula for alkane. To find any alkane, if the n is equal to 2, how many carbons and hydrogens will be there? Carbon will be 2, right? But how many hydrogens? 2n plus 2. 2 into 2
Okay,
plus
so
2.
3. 2N, 2N. So 2 times 2 is 4.
4 plus
Plus
2,
2 is 6.
6. That means hydrogen will be 6, right?
Yes.
So this is the formula for ethane.
Ethane.
Yes, ethane. So first comes methane, then ethane, and same thing. If n is equal to 3, how many will be C and H? Carbon number will be 3 as formula, but 2 into 3 plus 2 will be the H number.
So that is 2 times 3 is 6, 8.
8. That means this. So this is the formula for propane. And same thing, if it is 4, same thing happens. 4 and same thing to, that's the 2n plus 2. That means 8 and 10, right?
Yes.
So this is the formula for, we can say, butane. Butane. So these are all the formula for ethane, methane, propane, butane, and these are all alkanes at the end of the day. These are all alkane, and all the alkanes definition is something like this way, that all have a single bond. All have a single bond. What do you mean by that? I mean by that the hands are just in one, just one hands. And if I see, uh, if I make you watch another picture right here, you'll see that some hands have two, some hand has single bonds. Suppose alkane and alkyne. Okay, this, okay. See this uh, picture right here. You see this picture right here, I think you'll be a little bit clear. Okay, what is the difference between alkane, alkene and alkyne? Can you denote? There's something different about this three
Alkene,
picture.
alkaline, alkene, and wait, hold on. Okay, so yes.
Okay,
Okay,
so
yes, sir.
what's the difference between these three picture right here?
Alkene, alkaline,
Alkene, alkane, alkene, alkyne.
alkyne. Mm, they all have a different formula.
No, just observe it. How many bonds, how many hands are there in a carbon? See, there is one. Sorry, let me just five. Okay.
Wait, sir, what does the three lines mean?
Three lines means that carbon has like four hands, right?
Four, yes.
So all carbon's three hand is now focusing only one elements. That means at the end of the day, if we count how many hands are there in a carbon, we can easily say that there is one hands, right? In here,
Yes.
suppose I'm counting the hands of carbon. Can you count it? This is one, this is two, this is three, right? This is four.
Wait. Wait, that's also a hand of carbon. I thought that carbon and carbon. Wait, which one's a hand of carbon?
This one, this one, this one, this one, this one, right?
Okay, yes.
And same thing, if you count this carbon right here, how many hands? One, two,
Three.
three, and this one also four.
Yeah,
You have
four.
to count this. This is overlapping, right? So you
Yes.
have to count this again. So at the end there are four zero number of the hands of the carbon. Okay, so um, four is the number, and okay, so if you observe this one, how many hands is in this carbon? One,
Uh,
two,
wait.
three, four,
Just interesting. Okay. Four.
right?
Yes.
And how many hands in this carbon?
Oh, four, two.
One, two, three, four,
Four. Yes.
right? And
Yes.
how many hands in this carbon?
1,
right?
4 as well. 4.
1, 2, 3, 4. There are 3 lines here, right? And this one, this one,
Also 4.
1, 2, 3, 4, right? So all the
Yeah.
carbons represent 4, right? 4 hands. But these 4 hands can be adjusted, and by adjusting it we get alkane, alkene and alkyne, right?
Yes.
By adjusting it, suppose now 2 hands are focusing in one carbon, so this will be called alkene. That means alkenes means that double bond, that means 2 bonds are focusing, right, or bonding with each other, right? An alkyne means
Yeah.
that like triple bond, that means 3 bonds, right? 3 bonds are present, right? So
Yeah.
that's the difference between these 3 things right here. So alkene is like a single bond, nothing double or triple going here. Alkene, alkane means that an alkene means double, that means double bond is present here, and alkyne means triple, triple bond is present here. So that's the difference between this in these 3: single, double and triple. So do you understand the difference between these 3 things?
That's single,
Yes.
double, and triple. Yes. Yes, I do understand.
Okay. So the examples I have given, and if you observe these 4 pictures right here, methane, ethane, propane and butane, if you try to understand this picture right here, can you tell me, are they all alkene or alkyne or alkane? Is there any double or triple bond present in these 4 pictures right here?